Hey everyone, welcome back to Edu-Malanga. Today we are continuing with Unit 1, which is patterns, sequences, and series. We're going to do the first example for Lesson 2, which is geometric sequences. So let's get into example 1 of geometric sequences. Example 1 is a sequence that looks like this. 4, 6, 9, 27 over 2, and the last term we will write is 81 over 4. So this is a geometric sequence. Before we get into questions regarding this sequence, let's just remind ourselves of the general term of geometric sequences. The general term for any kind of sequence is always important because it is what you will use to find all the terms that are associated with that particular sequence. We'll understand this as we go on with the example, or if you still feel stuck at the end, go back and watch the introduction video of Lesson 1, where we introduce geometric sequences and we explain the general term in detail. So the general term of a geometric sequence looks like this. Tn, which is the term number, is equal to A. A is the first or the starting term of a sequence. A must always be defined when you are working with a sequence. And A is multiplied by R. That is the common ratio. You multiply the current term that you are looking at with the common ratio in order to generate the next term of the sequence. And R is raised to the power of n minus 1. So this is the general term for geometric sequences. Let's get started answering questions now on this geometric sequence that we're doing for example 1. First question we will answer, question 1, is what is the first term of the sequence? So what's A? And A is simple to find. You simply read it from the sequence. A is equal to the number 4 from looking at the sequence. The next question we will answer, question 2, is what is the common ratio of this geometric sequence? The common ratio is what we use to generate the next term of the sequence using multiplication. So for example, if you were to pick 4 as your current term, you'd have to multiply it by the common ratio and you would get the next term, which is 6. And question 2 is asking us to find it. So what we do is sort of the opposite. We start with the current term to find R. So R is equal to current term. And what we do is we divide by the previous term. And what's going to be left behind is the common ratio. Current term over the previous term is equal to R. And if we use the variables of geometric sequences using term numbers, we'll say that the common ratio is determined by Tn divided by Tn minus 1. So let's determine the common ratio of this sequence then. We'll start, for example, use 9 as our current term. 9 is term number 3, and the previous term, term 2, is term number 6. So to find R of the geometric sequence, we say T3 over T2, which is equal to 9 over 6. We have to simplify this expression, and what we use to do that are common factors of the number 6 and the number 9. A number that can go both into 6 and 9 is 3. So let's divide the top by 3. We'll divide both the numerator and the denominator by 3. And what we get is 9 divided by 3, that's equal to 3. 6 divided by 3, that's equal to 2. So from this calculation, we can determine that our common ratio is 3 over 2. Let's confirm the common ratio. We'll use another set of terms in the sequence to do this confirmation. I'm going to use term 5, 81 over 4, and term 4, 27 over 2. But if you are in a test situation, for example, I would advise you to rather use term 2 and term 1 because they're much simpler whole numbers. So the division will be simpler than using these terms. But because we're doing practice, Let's do the difficult ones. We're checking now term 5 over term 4. We're going to write it out differently. It will be 81 over 4 divided by 27 over 2. When you have two fractions and you're dividing them, what you normally would do is swap the denominator and the numerator of the second fraction, and then you change the sign from division to multiplication. So let's do it in the next page. Term 5 over term 4 then is equal to 81 over 4. And what we do is swap the numerator and the denominator. So this term becomes 2 over 27, and the sign changes from a division into a multiplication. And this is how you divide two fractions. This expression can then be simplified because 4 and 2 can go into each other. You can simplify this, turn this into a 1, simplify this, turn this into a 2. And again, 27 and 81 are both multiples of the number 9. So we can simplify. 9 goes into 27 3 times. So this can become 3. And 9 goes into 81 9 times. And this one can become 9. So we've simplified our expression. We'll then have 9 times 1 is equal to 9 over 2 times 3 over 6. And if we simplify further, we'll have division by 3 again over 3. And we get 9 divided by 3 is 3 over 2. So we've then confirmed that our common ratio R is equal to 3 over 2. The different ways in which this expression could have been simplified: you could have multiplied 81 times 2, 4 times 27, and then simplify the resulting expression. But I find it's normally easier to simplify when you're still looking at numbers that are not too big. The third question we'll answer for this sequence then is, what is the general term? Now that we have determined what A is and what R is for the sequence, we're simply going to use this expression as it is and substitute in. So let's rewrite it. Tn is equal to A times R to the power of n minus 1. So then for the sequence, the general term Tn is equal to, our A was 4 times 3 over 2 to the power of n minus 1. And this is the general term for the arithmetic sequence that we're looking at. The last question we will answer for this sequence will require us to use the general term. Question 4 is, what is term number 12 of this geometric sequence? The general term of the sequence is Tn is equal to 4 times 3 over 2, yes, to the power of n minus 1. Because we're looking for term number 12, wherever we see n, we're going to substitute. N is equal to 12. So the general term will become T12 is equal to 4 times 3 over 2 to the power of 12 minus 1. This can be simplified into 11. The general term will then become T12 is equal to 4 times 3 over 2 to the power of 11. When you have a power in a fraction, it's always important to understand that this power goes into all the terms of the fraction. So it's going to go into both the numerator and the denominator. If we expand in this expression, it will become 4 times 3 to the power of 11 divided by 2 to the power of 11. That's how a power works when you are looking at fractions. We're going to have to power all these terms, and this is where we use our calculators again. 3 to the power of 11 is equal to 177, 147, and 2 to the power of 11 is equal to 2048. So this is our expression. Let's simplify it. I'm pretty sure that 4 will go into 2048. So let's then divide 4. 2048 divided by 4 is equal to 512. 512. And the top term stays 177,147. We can't simplify this expression further. So this is our term number 12. T12 is equal to 177,147 over 512. And this is term 12 of the sequence that we're working with. We've now finished the final question on example 1 of geometric sequences. Join us in the next video. We will do another example on geometric sequences that will be more complicated than this one.